Hello again, fellow mathematicians. This is Miss Ledbetter, and we are ready to do some more math. Today we're looking at how do we solve quadratic inequalities. This is going along with our quadratic unit and solving quadratic equations. You need to be taking notes in your interactive notebook on page 28. Keep in mind you will have a quiz, and the quiz will come directly from questions on this video, so be sure that you are taking diligent notes in your notebook. So the first thing we're going to look at a couple of different examples. The first example we're going to look at is x squared minus 10x plus 18 is less than or equal to a negative 3. And the first thing that we want to do is we want to actually solve this quadratic equation using any of the various methods that we've already discussed in class. And just like we have done with inequalities in the past, previously, we solve the inequality exactly the same way that we solve an equation. So the first thing we're going to do is pretend that our inequality symbol is just an equal sign, and we're going to treat it as such. So we're going to solve the equation in the same way using any of the methods that we've already discussed. So the first thing that we have to do in order to solve the equation is we first have to make it equal 0. So the first thing I'm going to do is to add 3 on both sides of that equal sign. So then now my equation is x squared minus 10x plus 21 is now equal to 0. And then I'm going to solve it the same way that I would solve just a regular quadratic equation. So I'm going to, easiest thing to do is to see if I can factor. Is it possible to find any factors of 21 that could add or subtract to 10? Well, yes. 21 is 3 times 7, and if I just added 3 plus 7 gives me a negative 10, gives me 10. I need both of those to be negative so that then they would equal a negative 10 as their sum. So my two factors, when I factor that, would be x minus 3 and x minus 7 in order to make this equation equal to 0. So according to the zero product property, any way that I can multiply two values or two quantities to equal 0 is if one or both of those numbers were already equal to 0. So then therefore set each of those factors equal to 0 just like we have done before. X minus 3 is equal to 0, so then therefore x is equal to a positive 3. Or x minus 7 is equal to 0, and so then therefore x is equal to 7. So those would be my two solutions for my quadratic equation. However, let's go back to keep in mind, this is not actually an equation. I have to solve it using the equation rules, methods that we've already done, and then take it back to considering the inequality. So now when I go back to it, considering in the inequality form, the x equals 3 and the x equals 7 would be considered my critical points. So that is, yes, in fact, where it does cross the x-axis, but I'm not looking for where does it cross the x-axis. I want to know what are all the possible values of x that will make this quadratic equation, the x squared minus 10x plus 18, what values of x would make that less than or equal to a negative 3. So I want to know all of the possible x values, not just simply where does it cross the x-axis at this point. So in order to consider the inequality and to figure out the range of where the solutions would be, I have to consider every possible side or interval around those critical points when x equals 3 and x equals 7. So I'm going to simply choose any number that is less than the least factor, which would be the x equals 3, and any number that is greater than the greatest factor, which is x equals 7, and then also one value that would be in between the two. And depending on which one gives me a true solution, that will tell me where the intervals will lie in order to be considered a solution for this inequality. So I'm going to start with a number that is less than the least factor, which would be less than 3. So any number that is less than 3, I'm going to make my life easier, and I'm going to go with x is equal to 0, just because 0 is a really easy number to add, subtract, multiply, and divide, because you don't. So I'm going to take my x equals 0, and I'm going to substitute 0 in place of every x in the original inequality form. So rather than x squared, I'm going to say 0 squared minus 10 times 0 plus 18, whoopsie, change color, plus 18 must be less than or equal to a negative 3. And is that true? So 0 squared is obviously 0, minus 10 times 0, which is obviously still 0, then gives me 18 is less than or equal to a negative 3. Is that true? Absolutely not. So that is not going to be a viable solution. So it's not going to be anything that is less than 3. Let's try something that is greater than the greatest. Any number that's greater than 7. And again, I'm going to try to make my life easy by picking a number that's really easy to add, subtract, multiply. So I'm going to go with 10. 10 is a really easy number to multiply. So if I substitute 10 in place of every x, so then I would have 10 squared minus 10 times 10, haha, funny, plus 18 must be less than or equal to a negative 3. Now let's actually work it out, see if that is true. So 10 squared would be 100, minus 10 times 10, which is 100. So 100 minus 100 is 0. And then I'm back to 18 is less than or equal to a negative 3, which obviously, again, 18 is not less than or equal to a negative 3. So therefore, no, it is not going to be greater than 7 either. So then let's pick a number that is in between 3 and 7. Any number, I'm going to pick a number that's easy. Let's go with 5. 5 is another easy number to multiply. 0, 10, 5, can't go wrong with any of those numbers. So if I substitute in a 5, so then I would have 5 squared minus 10 times 5 plus the 18 must be less than or equal to a negative 3. Now let's check to see if that is a true statement. 5 squared would be 25, minus 10 times 5, which is 50. 25 minus 50 is a negative 25, plus the 18. So I'm actually looking at about a negative 7 is less than or equal to a negative 3. That actually, in fact, is a true statement. So therefore, that tells me, because the number that I picked in between my two critical points is a solution, it does give me a true statement. So then therefore, all of the values that are between the 3 and the 7 will be the solutions for this inequality as well. So then therefore, my solution for the inequality would look like 3 is less than or equal to x, which is less than or equal to 7. Or, if I wanted to put that in interval notation, I would have a closed bracket at 3 and a closed bracket at 7 as well. That's a 7, not a bracket. So we are including the values of 3 and 7 because the original inequality also did include an equal to the negative 3 value. So for those of you that need to have a step-by-step instruction, here is just a simple guidelines. When you're solving quadratic inequalities, anytime you're working with inequalities, first thing you want to do is pretend that your inequality is just simply an equal sign. And you solve that equation the same way that you would solve any other regular equation, whatever type of form that you may be working with. Just solve the equation anyway. And then for the quadratic inequality, once you have found the solutions, you found those critical points where it crosses the x-axis, so then you're going to pick any number that is within each of those intervals. So one that is below the critical point, so it's less than the least factor, one that is above, so it's greater than the greatest factor, and then also any number that is in between. And depending on which of those gives you a true statement, will tell you where your solutions for the inequality will lie. It's either going to be between or either or. So if your solution is above and below, if you get a true statement for both of those, then that would be an or. So it is, your solution is either less than the least value or greater than the greatest value, so that would be an or statement, so it's greater, going in opposite directions, same as we've done before with inequalities. And if your solution is in the in-between, that would be the and solution, and that would be the one that looks like the dumbbell on the number line, if you remember that from a previous video. Okay, so let's look at another example. This one, negative 2x squared plus 3x plus 7 is less than 2. It does have a leading coefficient, so it's going to get a little bit more complicated when we try to factor this one, but we'll go ahead and take a shot. So the first thing we're going to do is pretend that that inequality symbol is just simply an equal sign, and we're going to solve the equation in the exact same way we would before. So first thing I need to do for solving my equation is to make it equal 0. So I'm going to subtract 2 on both sides. So then now my equation becomes a negative 2x squared plus 3x plus 5 is now equal to 0. Sorry, that should have been in red. Oh well. Bracket up. Okay, so adding 5 now is now equal to 0. Okay, so then now I'm ready to factor my negative 2x squared plus 3x plus 5. So then I'm going to choose a different color, multiply the leading coefficient times the last term, the constant term. So a negative 2 times a positive 5 is going to give me a negative 10. And are there any factors of a negative 10 that can add or subtract to equal 3? Well, those two factors would be 2 and 5, because 2 times 5 is 10. But if I subtracted 2 from 5, would give me a positive 3. Since I need the positive 3, that means that the 2 is going to be my negative. So then if I go back to factoring by splitting the middle, so it's the exact same equation that we've had before, I'm just going to change the 3x to be my minus 2x plus 5x factors that I just found from my negative 10 plus 5 is equal to 0. And then I can factor each of these by grouping. So go to a different color again. So if I group a negative 2x squared and a minus 2x, between those I could factor out a negative 2x, and then that would leave me with an x plus 1 left over. And then if I group together the plus 5x plus 5, I could factor out a plus 5 from both of those, leaving me with, again, x plus 1. So then combining for my two factors, I would have a factor of a negative 2x plus 5 times a factor of x plus 1, making that equation still equal to 0. So then, again, just like I did before, take each of those factors equal to 0. Either one or both of those must already be 0 in order to make the entire equation become a 0. So if x plus 1 is equal to 0, then x is simply a negative 1. There's the first solution. And then if negative 2x plus 5 equals 0, so then I would subtract 5, divide by a negative 2, would end up being 5 halves, which is the same thing as 2.5. So those would be my two solutions there, x equals 2.5 or x equals a negative 1. So those are my two critical points. So again, taking it back to the inequality rather than the equation, looking at those critical points to determine which interval is going to give me the actual solutions for this inequality. I want to pick any number that is less than a negative 1, pick a number that is greater than 2.5, and then pick any number that's in between. And again, I try to make my life as easy as possible. So picking any number that is less than a negative 1, let's go with a negative 2. 2 is a good number to multiply, not too difficult. So if I use a negative 2 in place of everywhere I have an x, so then I would have a negative 2 times a negative 2 squared plus 3 times my negative 2 plus 7 must be less than 2. And then let's see if that's actually true. So a negative 2 squared, according to your order of operations, start with the exponent. So do the negative 2 squared is a negative 2 times a negative 2 should give you a positive 4 times a negative 2 would give you a negative 8. And then 3 times a negative 2 is a negative 6 plus 7. So a negative 8 minus 6, we're looking at a negative 14 plus 7. That's going to leave us with a negative 7. must be less than 2. Is that a true statement? Negative 7 less than 2? Yes, absolutely, that is true. Okay, so then let's check a number that is greater than 2.5. So let's say, let's go back to 5. 5 is another good number, easy to multiply. So if we plug in a 5, then we would have a negative 2, a negative 2 times 5 squared plus 3 times 5 plus 7 must be less than 2. Let's see if that's actually true. So 5 squared, again starting with the exponent, 5 squared is 25 times a negative 2. That would give me a negative 50. Plus 3 times 5, we're looking at a positive 15. So a negative 50 plus 15, and we're at a negative 35. Plus 7, we're at a negative, 28? Must be less than 2. Yeah, I'm pretty sure that that's going to be way less than 2. Yes, so that is true. And just on the off chance, let's just check one number that is in between, just in case it's possible that we may have all solutions. I don't think that's going to happen in this case, but, you never know. So go ahead and check all solutions. If there's any number that is between a negative 1 and a 2.5, let's go with something easy like 0. So if I substitute a 0 in place of every x, so a negative 2 times 0 squared, which is just going to give me 0, plus 3 times 0, again, that's just 0, plus 7 must be less than 2. So 0 plus 7 is less than 2. Is 7 less than 2? Absolutely not a true statement. So therefore, my true solutions would be any number that is less than the negative 1 or any number that is greater than the 2.5. And we want to include both of those solution sets. So our actual solution would look like x is less than a negative 1 or x is greater than the 2.5 or the 5 halves, both of those not being an equal to because the original inequality was not equal to, so it's just simply less than or greater than. So we've done a couple of examples, so now it is your turn to try. And again, here's a hint, note to self, these will be the questions that you will see on your quiz. So you need to make sure that you know how to do these ahead of time before you come to class. If you have questions, please ask. I will be available in the morning or after school. Just come and find me. Please ask before you take the quiz. So again, because of the length of each of these, you will need to take some time to actually work through them or just simply write down the answers. You can work through them later, but give yourself some time. Either pause the video or spend some time afterwards, just write down the answers and then verify that you actually did get that same answer. So for number 1, x squared plus 12x plus 39 is greater than or equal to 12. Your solutions would be x is less than a negative 9 or x is greater than or equal to a negative 3. So again, the original inequality is a greater than, so this would end up being an or. So it's following the same rules that we've had before with our inequalities. And then for number 2, x squared minus 24 is less than or equal to 5x. Your solution would be a negative 3 less than or equal to x, which is less than or equal to 8. And again, this time, the original inequality says less than, so that would end up being an and statement. So it would be in between the critical points of a negative 3 and a positive 8. So again, thanks for watching. Please make sure that you understand and you are able to show all of your work for these 2 particular questions. And if you have any questions, please come and ask ahead of time. Do not try to do the quiz without making sure that you know how to do these questions. And if you need to watch the video again, please watch the video again. Take some time, study for yourself, and be prepared whenever you come to class the next time. I'll see you later. Well, thanks for watching.